the fetch, decode and execute cycle. Let's examine a microcomputer system. This is the CPU. There is a program memory filled with machine codes, and a data memory which resides together with the special function registers. There is an instruction register in the CPU, and a program counter which its initial value is 0. The operation of the system starts off with a fetch cycle. The fetch cycle fetches instruction from the program memory to the CPU. The content in the program counter is used to determine where to fetch the instruction codes. When the program counter is 0000, the CPU prepares the system bus to fetch the code from program memory location 0000 hex. The content in location 000 hex is 02 hex. This code is fetched and placed in the instruction register. A sequencer hardware in the CPU automatically increments the program counter by 1. The fetch cycle is finished. The CPU goes into the decode cycle. Decode 02 is an incomplete code and cannot be executed. The CPU goes back to the fetch cycle. The next code to be fetched is at location 0001 hex. The code at location 0001 hex is 01 hex. This code is fetched and placed in the instruction register. The program counter is incremented by 1. The fetch cycle is complete. The CPU goes into the decode cycle. The codes 02 and 01 are incomplete and cannot be executed. The CPU goes back to the fetch cycle. Code at location 0002 is fetched. The code at location 0002 is 00 hex. The code is fetched and placed in the instruction register. The program counter is incremented by 1. The fetch cycle is complete. The CPU goes into the decode cycle. The codes 02, 01, 00 are complete and can be executed. These codes represent the instruction jump to location 0100 hex. The CPU goes into the execution cycle. In executing these codes, the CPU changes the program counter content to 0100 hex. The execution cycle is complete. The CPU goes back to the fetch cycle. The next location to fetch the code is at location 0100 hex. The code at location 0100 hex is 75 hex. It is fetched and placed in the instruction register. Program counter is incremented by 1. Fetch cycle is complete. The CPU goes into the decode cycle. Decode 75 hex is incomplete and cannot be executed. The CPU goes back to the fetch cycle. The location to fetch the code is 0101 hex. The code at location 0101 hex is 81 hex. The code is fetched and placed in the instruction register. The program counter is incremented. Fetch cycle is complete. CPU goes into decode. The codes 75, 81 are incomplete and cannot be executed. CPU goes back to the fetch cycle. CPU fetches the code at location 0102 hex. Code at 0102 hex is A0 hex. The code is fetched and placed in the instruction register. The program counter is incremented. Fetch cycle is complete. CPU goes into decoding. The codes 75, 81, A0 are complete and can be executed. This code represents the instruction move A0 hex to the stack pointer. CPU goes into execution cycle. The value A0 hex is written into the stack pointer which resides in the special function registers. Execution cycle is complete. CPU goes back to the fetch cycle. Where to fetch the next instruction? It is indicated by the program counter. The fetch, decode, execute cycle is the basic operational cycle of a microcomputer system.